example 3 here, we have f of x is x squared minus 5x, and then g of x is x plus 3. So we need to take f as our outside function, and we're going to input g. This is otherwise known as f of g of x. So f is x squared minus 5x. And we need to, now we need to input, that's our basic function, we need to input g. So there's a spot here for me to do an input, and there's a spot here for me to do an input. So for this, I have to go x plus 3 times x plus 3. I'm going to have to FOIL that, and here I can bring the negative 5 in, minus 5x minus 15. So let's take this and FOIL it. Expand this, x times x. X squared plus 3x plus 3x plus 9. Not x. And then we have the minus 5x and the minus 15. So we're going to have an x squared, 3 and 3 is 6, 6 minus 5 is just 1, so plus a 1x. 9 minus 5 is a minus 6. So there we have it. This is our composite function of taking g and inputting it into f. But we can work backwards. We can take g and input f. This is otherwise known as g of f of x. So g is going to be x plus 3. And we need to input f. And I forgot what f was. X squared minus 5x. So x squared, no, I don't even know what I just said. Minus 5x. And there's nothing to do this, we're not squaring it, so it's just an x squared minus 5x plus 3. And that's usually the case. One of the ways is often very, very simple, and the other one it has a little bit more required. Let's move on now to example 1, but the next one. And we're going to continue doing this, but then we're going to add in this idea of restrictions. And so let's just do a and b and then look at the restrictions after. So this is f of g of x. And we're going to take f. Now f is the square root of x minus 4. And we're going to input g. So I see a spot for it right here. We can input x squared here. Now, this, by the way, is not, you cannot square root that to get x and square root that to get 2. That's not the way this works. Take, for example, square root of 25 minus 16. Now, you should know that immediately 25 minus 16 is 9, and the square root of 9 is 3. So we should know that. But you might be thinking, well, the square root of 25 is just 5, and the square root of 16 is 4. And then you can just do 5 minus 4, which is 1. But you know that's not right. You know it has to be 3. You know 25 minus 16 is 9, and the square root of 9 is 3. So we can't just square root one of them, square root the other one, and then just do some sort of subtraction. So that's not the way this works. We can't do that. If you want to write this down as an example, you're more than welcome to. But we have to just leave this. So this is it. I am done this. There's nothing more I can do. Take this other example here. This is g of f of x. So you're taking g, which is x squared, and you're taking f and you're inputting it. So there's a spot for an input right here, and f is the square root of x minus 4. Now, square and square root, those are right beside each other. You can do that, so those can cancel, and you're just left with an x minus 4. And keep in mind that this is an x minus 4. Square root just means a power of a half, and then you're squaring it. And so 2 times a half is 1, which is why these are gone, and it's just a 1, and you're just left with an x minus 4. So that's why that ends up working. So this is going to be just an x minus 4. So now let's take a look at the second part, which is the restrictions part. And I don't know if you want to find a spot for this or write it on the side somewhere, but there's some restrictions that we need to know. So say you have the square root of something. Well, the restriction is you can't square root a negative number. So the restriction, so I'll put it right here, this is the restriction. The restriction is whatever this is here has to be bigger than or equal to 0. So bigger than or equal to 0. That is how we write that. This is the way of saying make sure it's positive or 0, meaning make sure it's not negative. So that's one type of restriction we can have. Another type of restriction that we can have is to have some sort of number or letter divided by something. And when we have that, well, the denominator is not allowed to be 0. So that's our other restriction, because you can't divide by 0. So this here, whatever happens to be, cannot equal 0. The third option is when we have a logarithm. So log base, 3 of something. Well, that something has to be positive. It can't even be 0. So the way to write that it has to be positive is say it's greater than 0. It can't even equal 0. It can't be negative and it can't be 0. So those are the three restrictions. And you could have, and this would be like this would be the worst, and I'm not going to do it. But you could have 5 over. So 5 over the square root of the log base 3 of x minus 2. And you might have to then find out all of the restrictions. There's a logarithm in here, there's a square root in here, and it's all on the denominator. So this would have 3 restrictions. So you can combine them. So I'm just going to leave that here, and you can pause it. But we're now going to use those to just to find out the restrictions on this other stuff over here. So let's start with b, because b is relatively straightforward. You look at your final thing here. There's no square root symbol. There's no logarithm. There's no fraction. There's nothing. However, you do have to take a look back at before you end up doing any canceling. So you're technically, this is your equation. We simplified it a little bit, but this is your equation. It has a square root symbol in here. So for your restrictions, which I'm going to write r, all you have is a square root. So you use this one right here. So the inside here has to be bigger than or equal to 0. So the inside is x minus 4. And it has to be bigger than or equal to 0. So that's number 1. So we're using number 1 here to do this. And then you can just add 4 to both sides. So x has to be bigger than or equal to 4. So that's it. You just do a little bit of algebra, and then you're done. Now the next one is not so easy. So we've got x squared minus 4 in a square root symbol. There was no simplifying. So the restriction here, exactly the same, is that it's the number 1. It's the x squared minus 4. The inside has to be bigger than or equal to 0. And then when you move over the 4 by adding it, so you plus 4 and plus 4. And then you have to square root, and so you get plus or minus the square root of 4 is 2. But it's technically not like that. It's not actually right. It is bigger than or equal to 2, and you wrote the other one, x is bigger than or equal to negative 2, if you wrote them separately. And the only thing you need to do, because this part is not hard, writing this out. Moving the 4 over is not hard. Square rooting, it's not hard. It might be a little difficult to remember the plus or minus. But the part that's the most difficult for me is, I think for most people, including myself actually, is just remembering that the negative version, you have to flip the symbol. So see how it's opening this way? So you leave that for the positive, but for the negative version, you flip it. So that is our restriction. X is allowed to be bigger than 2. It also is allowed to be smaller than negative 2. So for instance, if you had 5 here, you put a 5 in, 5 squared is 25, 25 minus 4 is 21. That's a positive number. You're allowed to square root it. And say you chose a number smaller than negative 2, maybe negative 5. Put negative 5 in here, negative 5 squared becomes positive 25. And again, 25 minus 4 is 21. So square root of 21 is positive. So that is how this works. So that is a much more difficult restriction. Both of these, there's no denominators, there's no logarithms, they're only a square root here. This one's sneaky because the square root has been canceled. So you have to just remember that. This one's sneaky because it has a plus or minus, and the minus you have to flip the symbol. So I'll zoom out here in case you want to write any of this stuff down. And in the next video, we'll do some more of these with some more restrictions.